traveled about 100 miles north of the U.S. border to Ontario, Canada. This is Kenora, a small town that makes a lot of strand lumber. Bill, nice to see you.
Nice to see you.
I can tell from what I'm looking at here, this is already a very big operation. You're the plant manager.
That's correct,
You've
yes.
got a big deal going on here.
Yeah. So this is where it all starts, Kevin. This is poplar logs arriving, about 8 feet long. About 50 of these trucks a day arrive on site to keep us going.
Unbelievable.
Yeah, it gets downpiled in the yard over there. You know, we've got about 4 or 5 weeks supply, but this is where it all starts, coming from the bush.
And the whole purpose of everything going on here is to make some LSL, Laminated Strand lumber, right?
That's correct. That's what we make here.
All right, well, you ready to show me the whole process?
You bet I am.
All right, thank you.
So Kevin, this is the start of our process here. So these are the 8-foot poplar logs that are being loaded into the process. We call those magazines. So we've got this high lift loader that takes the logs either from a logging truck or actually from our yard and loads them into those magazines. So then it's really the weight of those the logs in those magazines that push down into the conditioning ponds. So this is really the start of our whole LSL process. So this is the conditioning ponds and jack ladders. So the logs spend about 8 hours in the conditioning ponds. The ponds are heated up very hot, like 130 degrees during the winter, and it's really critical to thaw out the wood.
So primarily to thaw the wood and make it a little softer?
That's correct. During the winter, even during the summer, we'll have a little bit of heat on the ponds, you know, just to soften it up a little bit.
Big giant pond full of water. Machine brings them up here, and where's it dropping it?
It's dropping into a jack ladder outfeed conveyor, and that conveyor is going to feed the logs into debarkers a little bit down the stream. The logs also go through a metal detect conveyor, the gray thing right there.
Yeah.
So we really want to prevent any metal getting into our debarker or into our stranders. So Kevin, we need to remove the bark from the logs. So we have each of the logs go through the debarker singularly. And we've got 5 knives that rotate around the log and cut the bark off. And then the barks are ready for the next part of the process, which is stranding. So we've created a pocket of wood here, and that's going to get pushed forward into the Strander Ring. The Strander Ring is about 8 feet in diameter or so. It's got 48 knives around the interior of the ring, and it'll travel through the wood and cut the strand.
So that big ring there, that's the actual strander, and it's going sideways across the wood?
That's correct. It's driven by a 1,100 horsepower motor. And then it'll get indexed ahead for another cut. We're producing strands that drop off the bottom of that strander and go up the incline conveyor to some storage bins. This is one of 4 dryers that we have. The strands travel through here. They're being tumbled around like in a clothes dryer. And so they travel through to the end of the dryer. It takes about 15 minutes or so at about 1,000 degrees Fahrenheit to get down to the 2 to 3% moisture content that we need.
And what's the heat source for your dryer?
This is really the heart of the plant, Kevin. This is our one of our 2 fluidized bed combustors. Contains about 8 tons of sand, and we start it up with natural gas, get it all heated up, and then we add fuel made up of our bark that we take off the logs and off of sander dust or sawdust that we generate in the plant. So all the residuals that we generate essentially get burnt in our combustor.
Right.
We're producing flue gas off our combustor to dry our strands down to 2 to 3% moisture content, and then we're also using the flue gas to heat up thermal oil. When the plant was built, it was one of the largest thermal oil systems in North America with 80,000 gallons of thermal oil. And we use that thermal oil to really move heat around the plant. We use it to heat up the ponds, conditioning ponds. We use it to keep the plant warm during the winter. We use it to generate steam for our steam injection press.
Wow. So very, very efficient, no waste.
No waste at all. And this is the control room. This is where we manage and operate our energy system and our dryers in this area here. Mm-hmm. And over here we operate our blending, where we're blending strands with resin and wax. We're forming a mat through orienters to line up the strands in the machine direction, and that's outside here. And then we have a mat. Today we're pressing 1.5-inch wall framing products.
So essentially 2x4s that we use.
That's correct, yeah. The mat of strands is about a foot thick coming down the line. The forming process is a continuous one, so we have to cut that mat at some point. And we have a flying cutoff saw that starts to travel with the mat and cuts across. Then we accelerate the mat into the single opening steam injection press, which is very unique.
And how long is the mat, the one that you cut?
The mat's about 64 feet long,
Wow.
8 feet wide, and again about 12 inches thick for this product. It goes through the pressing process in a very unique steam injection press, which softens the mat with steam and helps cure the resin. After the mat then becomes, we call it a billet, and it'll actually go through a splitter saw that'll split the billet in half, 4 foot, 4 foot, for example, and goes down a roll case into a billet cooler. We need to cool it off for a couple hours so that it stops off-gassing.
Can you cut them once they're cooled?
That's correct. Then we go to our products area, which is really just a sawmill that cuts the billet down to size. We make something like 500 different products out of timber strand, out of LSL. This represents the kind of range from a 2x4 wall framing material, all the way to this 3.5-inch by 11/7/8-inch header that's used above garage doors and above walls and windows.
And everything in between.
And everything in between, yes.
Hi, Kevin. Welcome to our QA lab.
Thank you. What are we testing?
So today we're going to be determining the strength and stiffness performance of this 155 3.5-inch beam. So basically what we're going to do is we're going to take this beam and we're going to put it on this test frame. We're going to load it to a certain deflection. From that data we receive back from this test frame, we'll be able to determine its stiffness and strength performance and whether or not it met the required performance for this grade of product.
All right. That was a full-on explosion.
Yeah, that was a good test.
So it broke. What'd you learn?
So what we learned was it took over 4,000 pounds of force to break it, and the data is also telling me that it met its stiffness requirements or its MOE requirements. So we got a good test. Typically in the lab we'll do 4 more of those samples on the flexure machine, and then over there we're going to actually rip some boards in half on our tension tester.
Let's do that.
Okay. Okay, Kevin, what we're going to do here is we're going to determine tensile strength of this product. We'll turn the machine on and it'll basically just rip it in half.
So what am I looking at here? What are the different metrics?
So what this is telling us is basically the amount of load or pounds force it has on that tension.
Climbing fast.
Climbing fast, and it should break approximately over 30,000 pounds to actually bring it to failure.
30,000.
That's it.
That's unbelievable.
So that broke at over 35,000 pounds.
Wow. And so what would be a passing number? What's the threshold?
For this one, for this particular product, if you're above 20,000, you're in good shape.
So you're well above.
Oh yeah, we're well
Pass
above.
with flying colors?
Yeah, we're well above. That was a good test.
Congrats.
Okay.
So this is our automatic strapper where we're applying vinyl straps around the stack, every 4 or 5 feet or so to hold the stack together. Right. And then it gets transferred over to our bundle cut saw over here, which is really a horizontal bandsaw, and that's what we use to finally cut the 64-foot stack to lengths the customer needs.
So you've actually banded it while it's still 64 feet long.
That's correct, and we automatically know where the cuts are going to take place so we can position the banding. We now have bundles of LSL that are cut to length, and they're approaching our wrap station here. So at our wrap station, we're applying an end seal, a waterproofing end seal. We're applying waterproof wrap to our bundles. We're stapling it on, and then we're applying SAP logos and product information onto the bundle. And this is where the bulk of the people in the plant work, is actually at the wrap station.
Everything else is automated.
That's correct. Haven't automated this yet. We're working on it. This is our railcar loading bay here. We'll load out up to 25 railcar a week. and about another 75 trucks, and that's going to locations all across North America. In fact, we also ship some off to Japan.
Well, that is a lot of product. Bill, I really appreciate the tour, and I know we've got more of this coming to our house, so thanking you in advance for that delivery as well.
Thanks very much.
Appreciate it. Thanks for watching. This Old House has got a video for just about every home improvement project, so be sure to check out the others. And if you like what you see, click on the subscribe button to make sure that you get our newest videos right in your feed.